So here we go into chapter 3. The 3.1 is going to be lines and angles, and you know a lot of these. Parallel are obviously coplanar lines that do not intersect. On this cube, examples of parallel lines would be the lines along edges. This guy would be parallel to this guy. He would also be parallel to this guy. Those would be parallel lines. Perpendicular lines intersect at 90-degree angles. Example of perpendicular lines would be this guy and this guy are perpendicular. This guy and this guy are perpendicular. This guy and this guy are perpendicular. Skew lines are the ones that are new. They're not coplanar, they're not parallel, and do not intersect. They kind of look like perpendicular lines that will never intersect. So this guy and this guy would be skew lines. This guy will go on forever this way. This guy will go on forever, and it will also continue going up straight, so it will never intersect here. Let's find another pair. This guy and this guy. They're not parallel, but this line will keep going along here in the front, this one will come down in the back, and they will never intersect. Those would be skew lines. Lastly, using the Rubik's Cube, we'll talk about parallel planes. Parallel planes are planes that do not intersect. So if you can imagine that this top guy carries on that way, carries on that way, carries on this way, carries on this way, and this guy here at the bottom carries on, okay? This top plane will never intersect with the bottom plane here. This side plane will never intersect with the back side plane. Now that we've talked about special lines, let's talk about special angles. And first, you need to understand that there are special names for things. The first thing I want you to notice is that you have two lines, this line and this line. And there is this special line that cuts these two lines. So it just intersects two lines or more. This line right here is called a transversal. We're going to refer to this as T. And all we'll do here is call this line 1 and line 2. And notice that 1 and that 2 are subscript. Okay, so they're a little bit below the line that the L is on. And by creating this picture, I create 8 angles. So what I want to do is I just want to review 2 of the really special angle relationships. One is vertical angles, and one is a linear pair. You probably already have this flashcard, but vertical angles are 2 non-adjacent angles formed by 2 intersecting lines. So I have an intersecting line here and here. So I have created those vertical angles. I have also created those vertical angles. You can follow suit and say that 5 and 8 are vertical angles, and so are 6 and 7 vertical angles. I have also created linear pair. Again, you have a flashcard for these already. They are a pair of adjacent angles whose non-common sides are opposite rays. So if you remember, opposite rays are rays that have a common endpoint going in different directions. So this ray and this ray are opposite rays, and the adjacent angles would be 1 and 2. So I have a linear pair at 1 and 2. So angle 1 and 2 are a linear pair. But then wouldn't we also have a pair of linear pairs at angle 2 and 4? Well, following that, I'd have one at angle 4 and angle 3. And lastly, at angle 3 and angle 1. Then I have 4 more sets down here. So I have angle 5 and 6, I have angle 6 and 8, I have angle 8 and 7, and I have angle 7 and 5, all linear pair. We also create 4 other angle relationships: corresponding angles, alternate interior angles, alternate exterior angles, same side interior angles. First, you need to know what interior and exterior are. We're talking about interior and exterior based on the 2 lines. Again, this is my transversal. All of my angles are along the transversal. These are the 2 lines that the transversal intersects. So if I were to talk about inside and outside, this would all be interior because it's all on the inside of those 2 lines. This and this would all be exterior. Those are on the outside of those 2 lines. So let's talk about corresponding angles. Corresponding angles lie on the same side of the transversal, on the same sides of the lines. What does that mean? So they lie on the same side as the transversal. If this is my transversal, corresponding either both have to be over here or both have to be over here. And on the same side of the line. So let's take this line. We'll call this above the line and below the line. Take this line. We'll call this above the line and below the line. So they are on the same side of the transversal and the same side of the line. So the first example of these angles would be 1 and 5. Okay, so now we can move to the other side. 2 and 6 would also be corresponding angles. But don't forget, I have these angles that are underneath. So 3 and 7 would also be corresponding. 4 and 8 would also be corresponding. I like to remember these by using capital letters. They help me remember. So I call these the F angles. The F angles. And if you look here, if I make an F, even if it's backwards, it's going to be in the armpit of the F. Those will be my corresponding. Okay, what if I make this F? In the armpit of the F. So upside down and backwards, but it's still an F in the armpit of the F. Those would be corresponding angles. The next are going to be alternate interior angles. Remember what we said about interior. Interior is inside those lines, so everything in here is interior. So these guys out here cannot be considered interior lines because they're not inside the lines. So non-adjacent means not on the same side. So they lie on opposite sides of the transversal. Here's my transversal. They lie on opposite sides of the transversal between the lines. Well, I already know this is called a linear pair. So opposite sides of the transversal between the lines. So angle 3 and angle 6 would be considered, and angle 4 and angle 5 would be considered alternate interior. I call these the Z angles because if I make a Z, they'd be in the armpit of the Z. I can also make a Z this way. Armpit of the Z. Okay, alternate exterior angles. Remember the exteriors here and here. So they have to be on the exterior. They're alternate again. So I still look for a Z because the alternate. So here's my Z. But since they have to be exterior, I look for them on the top and the bottom of the Z. 1 and 8 would be exterior, alternate exterior angles. Same thing as 2 and 7 would be alternate exterior angles. Last are same side interior angles. And I bet you if you thought about it, you could figure out what these are. Interior, same side, or so the same side interior would be 4 and 6, or 3 and 5. I call these the C. Because if I draw a C, they're right inside that C. Your book doesn't talk about them, but there are such things as same side exterior angles. I bet you can figure out that they're on the same side as the transversal, but they're on the exterior. So same side as the transversal, but on the exterior. So 2 and 8, 1 and 7. So let's just run through a couple of examples. Vertical angles. I think you can see that in here 8 and 5 are vertical angles, and 4 and 9 are vertical angles. Linear pair. Linear pair, I know, are formed by a line, adjacent angles that one pair of sides are opposite angles. So 4 and 5 would be in a linear pair, 5 and 9, 9 and 8, 8 and 4. Corresponding angles. Can you find any? So the strategy is, look for a transversal. Here's a transversal. Look for angles along the transversal. Remember, here's inside this transversal and here's outside this transversal. And in corresponding, one has to be inside and one has to be outside. I don't see anything here that's outside, so there are no corresponding angles. What about alternate interior angles? Okay, so again, I'm looking for a transversal. What about this transversal right here? Remember, this is the Z angle, and I see a whole bunch of Z's here. Okay, so we're going to look at this transversal. So along this line, here are my two lines that cuts in half. So wouldn't this give me a Z? So 3 and 10 would be alternate interior angles. I'm sure you can find some more. If I make my Z backwards like this, 2 and 11 would be in the armpits of this Z. So 2 and 11 would also be alternate exterior. We've already talked about not being any exterior angles out here on the exterior, so there are no alternate exterior or same side interior or same side exterior. Now the same side interior, remember, are the C. So if I put a C here, My same side interior angles really need to be 2 angles. So this whole angle and this whole angle would be same side. So 1 plus 2 would be a same side angle as 6 plus 10. And that's it. Talk to you later.